this problem, we're trying to determine the percent yield. And so the first thing we have to do is determine the theoretical yield, which is just really a mass stoichiometry problem. So the first step, as always, is we need to have a balanced equation. So if we look, we have 2 oxygen, so I know I'm going to have to put a 2 in front. And then I also have now 2 times 2, which is 4 potassium, so I'm going to put a 4 in that blank. So then if I look at my problem, I'm just going to kind of label things. So it tells me that I have 4.28 grams of O2. So I'm going to go ahead, let me place a 1 in that blank. And I know I have 4.28 grams of oxygen. And that's going to be what, my superstar, which I know things about. And then it wants to know how much potassium, and it's kind of my recording box is in the way, but I want to know how much potassium oxide is formed, and so I need to know the grams of potassium oxide. So just like in cooking, I like to gather up everything I need before I start. So being that I see grams of O2, I'm just going to get over it and go up to the periodic table, look up O2, and I know that its molar mass is going to be 32 grams per mole. And then I know that I'm going to eventually need K2O's molar mass also, because I'm looking for grams at the end. And so if I look that up, I know that K is 39.1 grams per mole, and I have 2 Ks, plus I know I have 1 oxygen, so I'm going to have to add 16 to that. And so when you work that out, I know that it's 94.2 grams per mole. So I'm going to use that in just a little bit. So to start with, we can see that since O2 is our superstar, that our fractions are going to be 4 over 1, 1 over 1, and 2 over 1. Because again, we put what we know. We know oxygen's coefficient. He's the guy that we know something about. And so we're going to put those on the bottom. Now, before I can multiply by anything, because I need to get the relationships, I know I have to have 4 times as many moles of K as I do O2. I need to find my O2 moles. So I'm just going to do a little side calculation, and I know I have 4.28 grams of oxygen. And so if I divide that by his molar mass, which is 32 grams per mole, I'm going to end up with the number of moles of oxygen, which is kind of a small number because I know that 32 grams is 1 mole and I only have 4.28. And so just kind of like a little reality check to make sure that my number makes sense, and it is a decimal number, which makes sense. So 0.134 moles is how much oxygen I have. So I'm going to take that number, and I know I have 4 times as much as that, so I'm going to multiply by 4 to figure out my K, and I'm going to multiply by 2 to figure out my K2O. And I know it doesn't ask anything about K, but I like to give a big picture of what's going on so you can see what has to happen. So when I expand this out, go ahead and multiply it all out, I find that I'm going to have 0.536 moles of K will react with 0.134 moles of O2, and it's going to produce 0.268 moles of K2O. Now, that's not what I need, though. If you look on top of the K2O, I have grams. So we're just going to pop back on the mole wheel. We know that 1 mole has a mass of 94.2, so how many grams are in only 0.268 moles? So I'm just going to multiply that by the molar mass, which is going to give me the value that I'm looking for. And so I find that I'm going to form 25.2 grams of potassium oxide. So that gives me the first question, that 25.2 grams. Okay, so that is my theoretical yield. Because in theory, if everything was perfect, I should get that many grams of potassium oxide. But what it's asking me for now is what is my percent yield. So if I go up here, percent yield, the formula for percent yield is just my actual yield, what I actually got, divided by what I should have got, my theoretical yield times 100. So very, very simple. I just kind of remember alphabetical order. So percent yield is equal to the actual yield over the theoretical yield times 100. So I'm just going to fill in my actual yield. It tells me, it has to tell me this, so we have to actually do it in the lab. So we go into the lab, we perform this experiment, we weigh out how much K2O is actually formed, and that is your actual yield. It's just real life. Theoretical yield is not real life, it's on paper, it's what we calculated. And so in real life, we should get 25.2 grams, but normally things don't work out totally perfectly. And so what we want to do is see how well it worked out. So we're going to just divide those. It's kind of like when you do your test. Let's say you have a 30-point test and you make a 26 out of 30. Your max value is 30, you got a 26. Here, my max value is 25.2. I made a 17.6, and so that's pretty much the test grade for this lab is a 68.9%. And depending on the lab, that could be good, but your goal is to actually, just like on a test, get 100%. So that's how you work a theoretical yield and a percent yield problem.